Permission. Material open. Material కూడా open right? Open. Sorry. Yeah, good evening, everybody. Good evening. Am I audible there?
Yes, madam.
Yeah, is my screen visible?
Not in Zoom, madam. Please zoom it.
Zoom in. Yeah, I was actually trying to share both
Okay.
PDF and also the board. So that's why maybe my helper has really gone out just now.
That's why use only PDF, madam. No need to go with board.
Yes, sir. I will use PDF only. So we will go ahead with this problem.
PDF. Explain using PDF only.
We will go ahead with this. Yeah. So here in simplex problem, we have seen the graphical solution earlier. In graphical solution, there is a limitation wherein we can use it only when the number of variables are 2. Okay, because graph sheet has a limitation of only 2 axes. Okay, so simplex method, irrespective of how many ever variables are, you can use simplex method. Okay, but for the exam point of view, they might give a numerical with only 2 variables, x1 and x2. Okay, so now we will see here. So typically you are here he has given some examples. Let us solve one maximization problem and one minimization problem. Okay, so maximization problem, yeah, I'll take you to page number 56. Okay, so this is the table which you have to remember. Okay, so Cij, we call it as contribution per unit, and x1, x2, s1, s2 are variables. Okay, so we will encounter the variables like slack variable, surplus variable. I will be telling you what do you mean by that. Okay, so yeah, you can all relate with this problem, isn't it? Is the screen visible? I'm in which page? Just for confirmation.
Yeah, visible, but zoom it, madam. Zoom it.
Yeah, 1 minute, sir.
62, page number 62, but
yeah, I will zoom it, sir. 1 minute.
Use plus, madam, plus.
Yes, sir.
Yes, yes. Click on that plus.
No, sir. Okay. Yes, sir.
Still okay. Not able to see that full screen, madam.
1 minute, sir. I'll give me some time, sir. Meanwhile, I'll explain this. Okay. Yeah. So this is the numerical which we'll be solving. There are some typing mistakes in your material which you can rectify it in your material itself. Okay, I'll be telling you. Okay, so this is the problem. It is a maximization problem. Z is the objective function, is equal to 8x1 plus 6x2. Subject to how many constraints are there?
2, madam.
2 constraints. Okay, so both the constraints are less than or equal to constraints, isn't it? Yes. So this is a maximization problem with less than or equal to constraints. Okay, now when you are solving a numerical by simplex method, you can't use an inequation. Means less than or equal to constraint has to be converted into equal to constraint. Okay, now you tell me 4x1 plus 2x2 is less than or equal to 60 is there. Which side is lesser?
Left side.
Left side. So we add a variable there. Okay, we add a variable and that variable is known as slack variable. What is it known as? Slack variable. Slack variable. So this inequation, we have to convert that into an equation. Okay, 4x1 plus 2x2 plus 1s1, because the first slack variable we are using, we call it as 1s1, or you can call it as s1 only. Okay, s1 is equal to 60. So that is how we convert the inequation into equation. Second inequation, can you tell me how do you convert that into equation?
Plus S2.
Plus S2, very good, equal to 48. Okay, when you have changed the constraints, you have to change the objective also. Okay, so how do you change the objective? It is already equal to, isn't it? So what you do is, z is equal to 8x1 plus 6x2 plus 0s1 plus 0s2, you can write down there. Okay, so this is how we change the entire numerical to suit our requirements of simplex. Is that clear? Yes?
Yes,
I
madam.
come again.
Yeah.
Z is equal to 8x1 plus 6x2 plus 0s1 plus 0s2. This is how objective has changed. So our constraints are 4x1 plus 2x2 plus s1 is equal to 60. 2x1 plus 4x2 is equal plus s2 is equal to 48. Suppose if 3 constraints are there, you will add s3 also. Okay. Is this clear?
Yes, yes, madam.
So this is the first step. Okay. Now in second step, what you have to do, see, this is how they have changed. Okay. You need not expect it in the matrix form, that is fine. Okay. Even if you show the changed problem like this, okay, that should be fine. The given problem in the matrix form is as follows, need not show that. Okay. So that mathematical form you can show, that should be enough. Okay. Now step 2 is, you have to introduce these values in the table. Okay, you have to introduce these values. You have to introduce these values in the table. Okay, so now I will show you how do you introduce these values in the table. Okay, are you able to see the table? First the screen.
Yes, madam.
Yeah. Okay. Pen. Zoom the pen.
Yeah, now it's okay, madam.
Yes, sir. Use பண்ண முடியுமா? பண்ண முடியுமா இது? இங்க எழுத முடியுமா? Yeah. So can you see here? Yes. So here we have to introduce, these are known as basic variables. Okay. Basic கொஞ்சம் thin பண்ணிட்டா pen. These are known as the basic variables. From each constraint, one variable will enter the table. Okay. From each constraint, I come again. From each constraint, one variable will enter. The variables which we have added will enter the table. This is the initial table. Okay. This is the initial table. In the first constraint, which variable did we add? Which variable did we add? First constraint, which variable did we add? First constraint, which variable did we add? Yeah. First constraint, which variable did we add? Can you see here? Which variable did we add in the first constraint? First constraint, which variable did we add?
S1.
S1. S1. Okay. Second constraint, we added S2. Okay. So here in this table, you will have S1. Okay. You can see here. And S2. Are you getting the point? Okay. If you are having the study material, you can open that and check. Okay. So you have S1, S2 in the first table. Okay. So here the number of rows will be number of constraints. Number of rows will be number of constraints. Okay. Is it clear?
Yes, yes, madam.
So here, how we have to add is, see, these things are this XB, if you can make it Z, that would be better actually. Okay. Or let it be XB only. Here, you have to add all the variables which are there in the objective. Can you tell me the objective variables? X1, x2, s1,
S1, S2.
s2. And the coefficients which we have, those are known as contributions. What is the contribution of x1? 8. What is the contribution of x2?
6.
6. What is the contribution of s1?
0.
0. Contribution of s2?
0.
0. Are you getting the point? See here, if you can check here, 8, 6, 0, 0 are there. Above
Yes,
x1,
ma'am.
we have, above x1, we have written the contribution. Above x2, we have written the contribution. Above s1, we have written the contribution. Above s2, we have written the contribution. Okay. So contribution will appear in two places, here and also here. This is also contribution. The 0, 0 is also contribution. Okay. So these are all contributions, which we have to take it from the objective function. Okay. So now all the variables x1, x2, s1, s2, everything we have to take here, and you have to write the objective function over it, and constraint should be below. If you can tell me what are the constraints, isn't it 4x